Here's an interesting problem from the 1992 Mu Alpha Theta competition. We are asked to evaluate this sum of reciprocals of sums of cube roots. Now, for a problem similar to this that had square roots, we might be able to solve it by multiplying by the conjugate, which involves the difference of squares factorization. And that's what might clue us in to consider the difference of cubes factorization. It's not as nice as the difference of squares factorization, but there is a factorization for the difference of cubes, and this is what it looks like. Now you might notice the connection. The magic is all in this term here, a squared plus ab plus b squared. If we just ignore the cube roots here, look at this. You've got 1 squared plus 1 times 2 plus 2 squared. In the next term, 2 squared plus 2 times 3 plus 3 squared. 3 squared plus 3 times 4 plus 4 squared. You can see the pattern. They just got a bunch of cube roots, but the pattern is there. And the cube roots, although they make things uglier, don't really affect what's happening too much. Instead of 1 and 2 being the component pieces here, really it's the cube root of 1 and the cube root of 2. Instead of 2 and 3 being the component pieces here, really it's the cube root of 2 and the cube root of 3. So what we're going to do is rewrite all of these denominators by using a difference of cubes factorization and dividing both sides of this by a minus b. You'll see what I mean as we go through these. Beginning with this first term, the cube root of 1 plus the cube root of 2 plus the cube root of 4, that's the denominator, and we're just focusing on that because that's where the mess is. This is equal to 1 to the 2/3. We're writing it as 2/3 because you should be thinking about the cube root of 1 squared. Of course, that's still just the cube root of 1, but we're trying to make it look like this. The next term, cube root of 2, is the same as 1 to the 1/3 times 2 to the 1/3. Think a times b. And then the last term, the cube root of 4, is 2 to the 2/3. That's like 2 to the 1/3 squared, right? Now, when you think about the difference of cubes factorization, this whole thing is just this part. So what it's equal to is a cubed minus b cubed divided by a minus b. But as we've written this out, it's clear that a is 1 to the 1/3 and b is 2 to the 1/3. Although I would rather put the 2 first when we write this subtraction, and it's fine if I do that as long as I do it in both the numerator and denominator. So again, we've basically used this difference of cubes factorization with a equals 1 to the 1/3 and b equals 2 to the 1/3. Let's go through it again with the next term. The denominator right here is the cube root of 4 plus the cube root of 6 plus the cube root of 9. Again, we're going to try to rewrite it like this. The cube root of 4 is 2 to the 2/3. And then the cube root of 6 is 2 to the 1/3 times 3 to the 1/3. And then the cube root of 9 is 3 to the 2/3. In this case, we're thinking of a as 2 to the 1/3. A is 2 to the 1/3. And we're thinking of b as 3 to the 1/3. And again, we're just using this factorization. So if this sum of cube roots, which we've written like this, is this part of the factorization, what it's equal to is a cubed minus b cubed divided by a minus b. Or, as I'm writing it, b cubed minus a cubed divided by b minus a. And that's what you see here. 3 to the 1/3 cubed, which is 3 to the 3/3, minus 2 to the 1/3 cubed, which is 2 to the 3/3, divided by 3 to the 1/3 minus 2 to the 1/3. And then one last time, we'll carry out this procedure on the denominator of the last term. Cube root of 9 plus cube root of 12 plus cube root of 16. In this case, a is 3 to the 1/3, and b is 4 to the 1/3. And we proceed with this the same way as before. This thing is actually equal to this fraction. So now every one of these denominators we've re-expressed as these somewhat nicer fractions. For example, the first term, 1 divided by the sum of cube roots, well, that's going to be 1 divided by this fraction, which is just the reciprocal of the fraction. In each case, then, we're just going to have the reciprocal of these fractions, and they're all getting added together. So let's finish this up. Here is our original expression, and we've rewritten each of these denominators as these fractions. So plugging those fractions in, we're just going to have the sum of the reciprocals. These are the reciprocals of these three fractions. Notice each denominator is actually just equal to 1, right? This is 2 minus 1, 3 minus 2, 4 minus 3. All those denominators are just 1. And then rewriting everything else as cube roots, you have the cube root of 2 minus the cube root of 1, which is just 1, plus the cube root of 3, and so on. And now all we have to do is simplify to get our final answer. Cube root of 2 cancels out with the minus cube root of 2. Cube root of 3 cancels out with the minus cube root of 3. And so all that's left is the cube root of 4 minus 1. And that's the final answer. Let me know in the comments if you have any questions, and if you're looking for more interesting math problems, check out my playlist in the description. Please consider supporting Wrath of Math by joining as a channel member if you want to help support what I do and get early and exclusive access to certain videos, access to original music, and all sorts of other cool extras. Thanks for watching.
I'm the mathematical menace, the machinations of mankind. Two calculators at the same time, hand signs and abacus, finger count and calculus. I'm a V to the T, my parameter, the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me to Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponent